Hello everyone and welcome to another episode of Let's Code Duke Nukem, where we aim to recreate the original EJA action platformer released in 1991. Last episode we managed to get the game loop going and we can draw the part of the level that is visible. And in this episode we will implement a basic key handler that will handle the arrow keys for movement. Now since Duke is not present yet, we will move the camera instead. In addition, we will make the scrolling of the level a bit more true to the original game rather than the grid-based scrolling that is happening now. And finally, we will draw the background of the level, if it has one. Alright, so let's start by creating a key handler. And the key handler can extend the key adapter. And in Java, that is the class that will receive all the events from the keyboard when you press a key or when you release a key. So key pressed, key released. And we are interested in a boolean for up, down, left, right for now. And we'll add shoot and jump later. And we also probably have to handle like the escape key and some other keys. But for now, let's just do these. Let's make a private void handle key. Let's have the key code here and let's keep a boolean if the key was pressed or not. Then switch the key code and then case key event dot vk up. So if we pressed up, then up is pressed or not, and we need to break. We don't have to break anymore with this syntax here. VK left, left, and VK right is right. Alright, so in the key pressed we'll handle key E dot key code, and then the key is pressed true. Key released pressed false. Okay, so this will handle the arrow keys for us. Now we need to add this key handler to our game. So we'll key handler added here, and then key handler is a new key handler. And then in the initialize method, we'll add it to our graphics component because that's the biggest component of the screen. So we'll add the key listener key handler and we'll request the focus so that the correct component will have the focus so that the key strokes will be recorded. And then in the update method, let's handle these keys. So the delta X is influenced by the key handler. Oh, I need to make some getters for these booleans. Is up, is down, is left, is right. So if left is pressed, then we want to move 8 pixels to the left. Otherwise, if right is pressed, I want to move 8 pixels to the right, and otherwise I want to set delta X to 0. And then the same for delta Y, but then for the up and down directions. Alright, so now if I run the game, I should be able to control the camera of the game with my keys. And as you can see, we're still scrolling cell by cell in the grid, but we'll fix that in just a second. But you can see if I press up, it goes up, down, left, and right. Alright, so that's pretty cool. So that's the initial part of the key handling done. So this handle input is handled for us in this key handler. So that's nice. So now let's fix some smoother scrolling. Now the Duke game scrolls 8 by 8 pixels. Now the camera speed that we just defined here in this update method, I'll just make it a private static final int camera speed for now. Because if we snap the camera to these 8 pixels, better yet, let me public static final int tile size 16. I'm not sure if this 16 is supposed to go here in the graphics class. Let me just drop it into the graphics class. Width, height, scale, tile size. And the camera speed is then the tile size divided by 2. And then of course I need to put this stuff to 0. And I should put this on the top because that's where I put all my private static variables. Okay, so we got the camera speed set. So now the camera will snap to half grid cells all the time. So that means we can just update our render method here to do some smoother scrolling. So the way that we'll do that is we'll start by calculating the grid position where we need to start checking for tiles, and that is the game state.getCamera x divided by the tile size. The grid y position is the game state camera y divided by the tile size. And then the scroll offset, scroll x, is the game state camera x modulated by the tile size. So this is going to be a value between 0 and 16. Same for the scroll y. And here we can start the row at the grid y position. And we'll go grid y plus 12. Y plus 12 because we're scrolling, so we need an extra strip around the edge of the screen. So if we said that the screen was 10 by 13 cells large, but because we're scrolling we need an extra strip around it, so yeah, it's 12. So here instead of 13 we're going to go 15, so this is grid x plus 15, grid x. And then here we can just instantly refer to row and the column. And then we need to calculate the correct screen offset here. So easiest way is to just keep a screen y variable that starts at the negative scroll offset for the rows, and then for the columns we'll start screen x at negative scroll x. So we can just draw at the screen x and the screen y, and then here we'll just increment the screen x by the tile size, and here we'll increment screen y by the tile size. And this should give us some smoother scrolling. Let's give it a go. So here we can see that the scrolling now goes by half tiles. If you look at, for example, this nuclear waste barrel, now we only see a quarter of the tile there. So this is how Duke Nukem uses scroll. Now it looks kind of weird, of course, with the level appearing out of the black area right there, but the original game had the heads-up display here with the borders and the score and the inventory on the right, so it will be hidden by those borders and it will look pretty smooth. Just for laughs, let's increase the size of the rendering area to fit the entire screen, so you can see potentially how it looks during gameplay, and I think it looks kind of nice. Let's go back. Okay, so one thing that's missing from our current level here is the background of the level. It's all black at the moment. So let's quickly fix that as well. And we need to make sure that we do not exceed the array of the tiles here. So what we'll do is we'll just do a check of the row here. So we want to make sure that the row is bigger than 0 and that the row is smaller than the height. And we want to make sure that the column is bigger than 0 and that it's smaller than width. And if that's the case, then we want to grab it from the array, and otherwise we're just going to return tile 0, which is an empty tile. So now if we are to wander off the level boundaries, if we go way too far, the game does not crash. Okay, so that's that. So let's add the background image for the level. So let's just add it here, buffered image backdrop. Buffered image backdrop. And then the resource loader needs to know which backdrop belongs to this level. For now, I think we'll just do drop1.dn1. Does it exist? Drop1. We got drop 0 as well. Okay, let's do drop 0. And let's pass it here. And then once we have the backdrop, we can render that right after we cleared the screen. So if the level game state get level get backdrop, I need to add a getter for the backdrop. Get backdrop. If the level has a backdrop, draw it. All right, it's not drawing this backdrop for some reason. Which is, oh, I need to assign it here. This backdrop is backdrop. Okay, let's try again. Okay, so here we have a floating city backdrop. It looks kind of weird now, but I think it'll look better once we draw the border. And here we do see a problem that we assume an alpha channel on these background sprites, which I think should actually be plain black rather than transparent. Right, you can see the background bleeding through the these images here. So let's fix that as well. We should make those black by simply assuming that all the tiles, the solid and the background tiles in the level, are supposed to be fully opaque. That way the opacity and the transparency will be reserved for special objects such as items and enemies and stuff like that. But I think it'll be fine if the tiles of each level are just going to be fully opaque. So let's start by adding in a override here that we can say, like, even if the tile file has a alpha channel, we're just going to fully make everything opaque here. And then here in this if, we can say, like, okay, if it is opaque or if the opacity bit is set, then we'll just assume that we need to plot the pixel. So that is step 1. This will result in some things we need to fix here. So for a backdrop, we can assume it's fully opaque because nothing comes behind the backdrop. And then here for these retiles, we need to pass in the opaque flag. Then there's one related problem, and that is here in the init method in the graphics component. We'll delegate this to the resource loader. So here we can say that the tile set is going to be loader.getImage. read tiles. And then here we'll make a new read tiles method. That returns this stuff here. And then here we need to pass in true, that we say like everything that we read for the tile set has to be considered opaque. And then here we can actually override this with our own read tiles. So this still works as well. Then if we run the game, we can see that we're overriding the background now with a fully black tile, which is tile number 0. So what we will do is, where we check the tile ID to be less than 3000 hex address, we'll also check if it's larger than 0, so that we won't bother drawing sprite 0, which is an empty tile. And here we can see the background in all its glory again. And now we can see that the background tiles have proper black linings and everything looks better. All right, I think that will do it for now. And in the next episode, I think we will actually start drawing in Duke and see if we can collide with the level geometry. So thank you for watching. If you have any questions or remarks, feel free to leave them in the comments below. And if you are enjoying the series so far, then don't hesitate to leave a like. And as always, I'll see you guys in the next episode. Bye-bye.